So example 5, can you help me read the question itself? Chanel's not here. Anthony, help me read example 5 question, please.
The equations for freefall near the surface of Mars and Jupiter, S in meters, T in seconds, are Mars S equals 1.86 T squared, Jupiter S equals 11.44 T squared. How long would it take a rock falling from rest to reach a velocity of 16.6 meters per second, about 60 meters, kilometers per hour on each planet?
All right, so Anthony did a great job reading. What are we looking for? How long means the time? The time what? You're right, we're going to look for time to reach a velocity of 16. So what do we do? How do we set it up? There's a lot of stuff in there, lots of numbers. What do we do to find our time? What do we do? How do we start? How to execute this question? How long would it take a rock falling from rest to reach a velocity of 16.6 meter per? Find the derivative. You're right, independently, right? Because it looks like each planet has its own equation. So Mars and Jupiter. So the equation for Mars is 1.86 T squared. The equation for Jupiter is 11.44 T squared. So the derivative, which is S prime of T, equals to what? 2 times 1.86 times T. So 2 times 1.86 is what, Marco? Help me out when you're ready. 3.72 times T. Okay. What do we do with that? The derivative of position equals to...
Would you set that equal to 16.6?
I would, because the derivative isn't that the velocity?
Yeah.
I'm interested in looking for the time when the velocity is what? 16.6. You're right. So divide both sides by 3.72. If you can do that in your head, great. If you can't, bust out your calculator. Approximately about what time? So, Amy Doe, whenever you're ready, give me the approximation of time. 2 decimal places will be sufficient. 4.46 seconds. So in about 4.46 seconds on Mars, this object will have a velocity of 16.6. Mm-hmm. All right, you try Jupiter. You let me know about what time. Approximately what time on Jupiter would it still reach the same velocity of 16.6? Faster or slower on Jupiter? You ready to go? Yep. Okay. So on Jupiter, on Jupiter, about what time, Aiden?
1.73 seconds.
1.73 seconds. Someone confirm that for me?
Yeah.
Perfect. Perfect. Okay. A lot of this is, do you know what is asking? Do you know the language? So the language is really new, and some of them are kind of asking the same thing. Okay. Number 6, can you help me read number 6? Trey, just that very first, actually, you know what? Read all parts of number 6.
Find the rate of change of the area of a circle with respect to its radius.
Oh, sorry, it's supposed to be it's, not it is. It, not it is, radius.
Evaluate the rate of change of the area of a radius of 5 and a radius of 10. Find the average rate of change of the area of a circle from radius of 5 to 10.
Okay, very good. Find the rate of change of the area of a circle, let's call it A, with respect to its radius, let's call it R. What do? Write out the equation. What kind of equation are we writing? Area equation. So it said area is A, so A equals what? Pi r squared. Okay, so that is the area of a circle equation. It says find the rate of change. What do? Find the derivative. How do we find the derivative? A prime is 2 pi r. Can someone tell me what that is? What? How does that make sense? Analyze that for me. Why is the rate of change of a circle equal to the circumference? What's that mean? Make sense of that value. I see motion. Spit it out. What does it mean? Why is the rate of change? It's a change in circumference. He has an answer. Yes. What's your answer?
Yes, Tony, what's your answer? Could it be that because when your radius is, your area is dependent on the radius, so then when the radius is getting larger and larger, it increases the area, which holds it to the radius.
Do you guys agree? So the rate of change, right? The rate of change depends on, it becomes the circumference. So think about an onion. Let's go 3D. An onion. What happens? You peel off a layer. Yeah, the volume. So guess what? The derivative of a volume formula is really the surface area. Why is that? Because remember, the rate of change means what? Every time I change, just like what I said, every time I change a small amount of radius, right? In a circle, think about circles made of a bunch of different circumference, right? Just stacked together. So every time I change it, right? Just a change in area, that means I'm just taking one small layer of the circumference. Would you agree? That's why. The same thing with 3D. Volume, if I want to change the volume, so the rate of change of a volume is really the surface area. Because I'm just peeling off a layer, right? So that's why they're related. Really cool, right? All right, language. Evaluate the rate of change of A at r equals 5 and r equals 10. What do I mean by that? Plug in that for which? A or A prime? A prime. Very good. Okay. So A prime at 5 is 2 pi times 5, which is really what? 10 pi. Now the unit of measurement. Okay, remember it's this change in y divided by change in x. So normally if they give you the feet or meters or whatever it is that they want to give you, then we want to do the area, which is whatever it is. So area unit over radius unit. Okay, so since they don't have any units of measurement given to us, we'll spell it out so in the future we would know. Why don't you evaluate at 10 for me and let me know what you get? So at 10, what is the rate of change at 10, David D? Oh, that is a funky too. 20 pi, and then again in the future, if they give you meters or feet or whatever it is, then you use it correctly. But since they didn't give it to you, we'll spell it out. So area unit over radius unit. Okay, C. Find the average rate of change of A from radius being 5 all the way to radius being 10. Is it the same answer? No. What do we do here from the average rate of change? What are you looking for? Say it because I can't hear you. Is it the slope?
Yes.
Yes. If you see the word average rate of change, that's kind of like algebra 1, find the slope, which is not the derivative, right guys? Okay. Rate of change, which is instantaneous. Average rate of change is not. Okay. All right. What do we do? Delta y divided by delta x. That's the same thing as saying area at 10 minus area at 5 all over 10 minus 5. So area formula was pi r squared. So that's going to be pi times 10 squared minus pi times 5 squared all over 10 minus 5, which is 5. 10 squared is what? 100 pi. Take away 25 pi. That sounds delicious. With some ice cream? Okay. Equals 75 pi over 5, which is 15 pi, which is now area unit over radius unit, okay? Are you shocked that this value is different than the first part B? Should it be different? The average rate of change versus the instantaneous rate of change? It should be different, right? How do we compare the two? What would be the language? How do we analyze the two? What would you say about the average rate of change? How would we analyze that? What does it mean to have the rate of change at 5 or 10 or at What does the average rate of change mean from 5 to 10? What does that mean?
So the radius is bigger, what happens to the...
Yeah, so radius is increasing, right? The area, what's happening area. Some may be more steep, as you can see at 10 is quite steep, right? The change is more significant. Some may not be as significant, but overall, this is the value. Okay, so the average means an overall. Any questions on using when to use the average and when to use instantaneous? Marginal cost. Let me talk to you guys about marginal cost and marginal revenue. So marginal cost is also calculus. Okay, ready, MED? Marginal cost, and normally we talk about production, like making t-shirts, making erasers, making pancakes. Okay, marginal cost, and normally again talk about making stuff, okay, is the rate of change. Whoa, that word again. The rate of change. What is that? The slope. It's the rate of change of cost with respect to the level of production. Normally we write d of c all over d of x, where c of x is the cost. Is the cost needed to produce X products. Bless you. Okay. Whoa, where did that go? D of C, yeah, over D of X, where C of X is the cost, and then X is how many items you are making. Revenue is the same thing, except, by the way, what is a revenue? What's a revenue? If you own a business, what's a revenue?
The entire money that you...
The entire money that you collect, right?
Yes.
What's profit?
The difference between
The difference between the cost?
Minus cost.
Yep. Right, so take the revenue, subtract your cost equals your profit. Hopefully it's on the positive side. Otherwise you'll be out of business really quick. Okay. Marginal revenue It's the same model, except we're talking about money collected. Okay. The marginal revenue is the money gained or collected. Okay. From selling X products. Okay. And we're talking about one, so anytime you're talking about marginal revenue or marginal cost, it's always the rate of change. So I want to put down rate of change. Okay. Normally you're going to see dr over dx, and guess what dr is? Or guess what r of x is? It's the revenue. Okay, so revenue, and x is product. Revenue collected from selling X product. Okay. Okay, let's use that on example 7 right away. Example 7 is your last example. Ryan, help us read example 7, just line number 1.
Suppose that the dollar cost of producing X washing machines is C of X is equal to 2,000 plus 100X minus 0.1X squared.
Thank you. Okay, so let's talk about this equation really quickly. You can see that there's variables and there's this big number, 2,000. Anybody know what 2,000 is? What if you have X is 0? What will be the cost? Yeah, so what is that called when it's always there? Constant cost, initial cost, fixed cost. What does that mean by fixed cost? It's always there. Whether you produce 1,000 machines or produce what? 0 machines. It's there. So it's there because you still probably have to pay for the stuff, right? To eventually make for it. Okay? The tools. Okay. The factory, it's already there. Paying people, that's not doing anything. You have to pay them anyway. Right? So that's your fixed cost. Now, number 1A, I'm sorry, 7A says find the average. Is that derivative? Okay, but here's where it's going to be slightly different. The slope we know from algebra 1 is the change in y divided by the change in x. This one says find the average cost of producing 100 washing machines. If I go in and I said find the cost for producing 100 machines, what would you do? Plug in 100. But I said I want to find the average cost. What would you do after you plug in 100?
Divide by 100.
You divide it by 100. Would you agree? Okay, so the average cost of producing 100 is the cost of all 100 divided by 100. Does that make sense how that goes? Okay. So I will write down the equation really quickly. So the average cost is the cost of 100. Once you find the cost of that, you're going to go and do what? Divide it by 100. All right. How do we find the cost of 100? Plug it in. 2,000. This is where I'm going to definitely need your calculator user. Okay. Plus 100 times 100 minus 0.1 times 100 squared. All of that. Divide by 100. All right, crunch it out in your calculator. What does your calculator skill say? What is the average cost for each machine?
Wow. Take it away when I'm already there. That's just so enormously rude.
So the cost of all machines divided by however many machines.
11,000.
11,000 per machine? No.
So divided by 100.
Oh, okay. So Edison, how much will it cost on average per machine? $110 per machine. Okay. Yeah, my washing machine's broken right now, so I can definitely, if it's $100, I'm like, dude, how do people live without a washing machine? I'm dying at home. I'm just like, oh my
Do
gosh.
you have like a river nearby?
Go down there.
Go to the ocean, you know, just throw them in. Go get your
Have you ever
clothes.
thought about like pre-machinery times? It's like, how do we live? You know, like, yeah.
When I visited my family in Mexico, they don't have washing machines, and so they have like this big, like kind of pool where the government sends them monthly water, and they use that water for everything. Like they just grab the water and they start washing the dishes with that, and then they have a rock on the side, and they just start scrubbing the all their clothes, and then they just dry it off with the water.
I
like
know.
wash it off.
I'm gonna send it to my mom. Be like, Mom. Yeah, but we're dying at home. I'm like, oh my gosh, oh my husband, like, get it fixed, quick. Okay. And yours broken too, right? How do you guys do it at home?
I don't even know. We're actually getting a person coming tomorrow to fix it.
I know. Actually, yeah, tomorrow's Wednesday. My person's coming tomorrow too. Wednesday.
Just rub some deodorant on your clothes. Okay, this is fine.
I told my trip, like, you cannot put any of those in the dirty laundry hamper because I can't touch them for like I don't know when. So they're like wearing clothes again a couple of times. Like if somebody said you're smelly, I'm like sorry, it's working. Okay, B. Find the marginal cost. Okay, here's the word marginal. Find the marginal cost when 100 machines are produced. Now what? Find the derivative. Okay. Derivative of what? The equation. So let's find C prime of x. So C prime of x is, what's the derivative of 2000? 0. Derivative of 100x. 100 minus what?
0.2x.
0.2. So I'll write the step down. So 0.1 times 2 times x, that's how we get 0.2. So that's really 100 minus 0.2 of x. But I'm looking for, find the marginal cost when 100 machines are produced. What are we going to plug in? 100. So equals 100 minus 0.2 times 100. So what would that give us? Punch it in. Let me know. Actually, you don't even have to punch it in. What's 0.2 times 100?
20.
20. 100 minus 20.
80.
$80. Oops, I wrote 10. But what does it mean?
That's the 100th machine.
No, it's not a hundredth machine. Your marginal cost. Marginal cost, it is the derivative. Okay. So
The cost needed to produce.
it's the cost needed to produce one more. Okay. Think about instantaneous, 101. Instantaneous is, right? So this is the cost of producing 100 and the first machine. Okay, so let me spell that out so you have a better understanding. The cost of producing 101th machine is what? $80. Okay? Why do I keep writing 10? It's $80. So by interpretation, that's really what it means. It's the producing one more machine, or it's the selling one more product. Would you agree that every machine that you're going to produce is going to be slightly cheaper? Right? Until a certain point, and then it goes back up. But that's what it means. So what if on the test I said, find the cost of producing 100th machine? Then you would do 99. Okay? So the language, that's what I'm saying. Calculus is all about the language. Marginal cost is producing one more. Okay? Marginal revenue is selling one more. Okay.
So is that rule like only for like word problems like this?
For all calculus problems. Even instantaneous is really
Like
technically.
all the ones we've been doing?
Yeah, so instantaneous is always like, right, that's why some questions they write it like, is if I'm an instantaneous rate of 5, technically that's really immediately right after 5. You know?
5.2.
Yeah. So it's always like,
But then when you put it in a real life application, you can't have 0.001 washing machine. So, okay.
You'd have to round it up.
Now, on letter C, it says show that the marginal cost when producing 100 machines are produced. Show that the marginal cost when 100 machines are produced is approximately the cost of producing one more washing machine after the first 100 has already been made by calculating the latter cost directly. So we're going to prove why this is 100 and one machine. Okay? We're going to do it algebraically to see if calculus is really okay, if it's legit. Okay? Algebra is always right. We're learning calculus for the very first time. We're going to see if it's okay. So I would like to know, what's the cost of producing 100 machines? Total cost. What do you think that is? Do we know how to find it?
Yes.
What is it? We did it already. What was the numerator?
11,000.
11,000. When we plug it in into original, right? 11,000. Then I would like to find the cost of 101. And guess what my goal is? Subtract the 2. All right, let's find the cost of 101. 2,000 plus, the original was 100, minus 101, minus 0.1 times 101 squared. Someone give me that number. So total cost for all of 101 machines is what? Hopefully more than 11,000 if we did it right. What is it?
11,079.9.
Oh, so 11,079.9? Yeah, so how would we find the difference between 100 and 101? Subtract the 2, right? So algebra-wise, this is what we would do back in the days before calculus was invented. Would you agree that's okay to do? So what's the difference then? 79.9. So algebra is more accurate, but calculus is a little bit off, but which one's quicker? Yeah, that's why calculus. So calculus is not exact, but it's much quicker, especially when the equation is so difficult to do. So this is the cost of producing 101. Okay, so this is our last, this is a summary. Okay, when do we know to use derivative? When I ask you to find the rate of, the growth rate, that's also derivative. The rate in which, how fast number, speed, and then obviously we just learned what? Marginal. I will also ask you to find velocity. Velocity is the derivative of what? Position. And then acceleration is the derivative of velocity. If I ask you to find the average of anything, are you using derivative?
No.
No. Right? Rate of, yes. Average of change, no. Okay? All right. Go ahead and grab your book.